Good morning. My name is Rian Singh Rana from Functional School of Technology, pursuing my BTech in CSE with specialization in AI ML here. So I'm here to explain you the solution to the lead code question 065 with the title Can Place Flowers. So the question says that you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in the adjacent plot. Given an integer array flower bed containing zeros and ones, where zero means empty and one means non-empty, and integer n return true if n new flowers can be planted in the flower bed without violating the no adjacent flower rules, and false otherwise. So the basically what we have been given is that we have been given an array, and that array is the basically the image of an flower bed, and inside the flower bed there are some rules for placing plants. So the rule is only one, that there cannot be adjacent plants to adjacent plants. For example, if there is planted one, if there one is planted over here, then the next plant cannot be planted right next to it. Instead, it should be planted by leaving a gap of one plot between two of those plants. So, for example, over here, this array is the flower bed that we have been given as an input, and there are two plants planted inside that flower bed, which is represented by one in the end of the flower bed. So, as you can see here and here, these are the three empty plots within the flower bed. So, we have to check if we can plant one more plant inside that flower bed, and as you can see, we can plant one plant over here. We cannot plant it over here because then two plants would be adjacent over here, and similarly over here as well. That's why only one plant can be planted in the center of the array. Hence, the answer is true. And for here, the array is same like from the previous input, but just the difference in this example is that the number of plants it is asking for us to plant is two. So that is not possible in this case because there is only space for one plant within in the middle of the whole flower bed, or you can say the array. That's why answer is over here is false. So the code for this is really simple. First, what we do, I simply change the name of the flower bed to F just to for my convenience. So first, I created an integer type length variable which will store the length of the whole flower bed, and then I'm simply counting the number of empty plots which we are able to plant, or we can plant more plants on. So this is the counter for that only. Now here, I simply did the I simply initialized a for loop with the loop variable as a zero, and the condition for the for loop is that it would iterate the whole array till length, because as we know that I am using I over here as the index of the whole array, and it would go till length minus one, that is the last index of the whole array. And after each iteration loop iteration, the value of I would be incremented by one. So the first condition that we are checking if whether the element present inside the flower bed at the ith index is zero or not. If the element present inside that element or at the ith index is not zero, then it would skip this whole code of block. As you can see, this if command comes till over here. So it would skip all of this, and then it would go to the next loop iteration because the condition isn't met. If the condition is met, then I initialize another variable. It is known as previous. This is the short abbreviation for the previous. I am using P over here for the previous, and I initialized it with zero. Now I check if the element that I found, which is zero, is at this beginning of the array or at the end of the array. Why? I'll explain it in the next kind of line of code. So this I is checking if that the index of I is greater than zero. Now zero over here represents that if the element that I found that is not that is zero on the ith index, if it is the first element, so zero represents the first element of any array. So it is simply checking that. I am checking that because I need to assign the I need to assign the value to the p which would be previous to the current iterated index. That's why I'm checking if it is the first index, because if it is not the first index, then what would happen? It would simply give us an array of giving saying that we cannot find anything that is out of bound of this array, because if the I is or is equal to zero or less than zero, then it would of course give us the out of bound error. Now, if it is greater than 0, which means that either it is 1 or more than 1, the value of the index, then it would simply assign the p-value, the previous plot, or you can say, for example, if I is over here, then it would simply assign the p-value of this element, or you can say it would simply assign the element of this value, which is previous to the ith element. Now, after that condition is satisfied, or that auto block has run, it would go and then I initialize next variable, next int type variable, which stores 0. Now here I'm checking if the ith value that I am currently on is the last of the index, because I want to assign this variable the next plot's value. That's why I'm checking it, because if, as I previously mentioned, if I do not check this for this condition, then and I simply assign I plus 1 index value to the next variable, then an error would be thrown to me, which would say that the current index is out of bound of the array. So if it is not outside, or in our case, if we, let's say I is over here, then it is not at the end of the index, or you can say it is not on the end of at the end of the array. That's why the condition would be satisfied over here, because the length minus 1 represents the length of the last element's index. So after that, you can see that I'm simply assigning the next variable, the I plus 1th index element in the array. After that, I'm simply checking whether if p is equal to 0 and next is equal to 0. Why we are doing that? Because as we know, and if we want to plant a new plant in the current plot, then the value of the elements coming before it and after it should be 0, which means that there should be no plants planted before it and right after it, which means that the plant is not we are not planting any plant adjacent to any other plant. That's why this condition is really important, and we used and operator over here, not or operator, because then it would give us the wrong answer. And if that is possible, then we simply replace the value of the ith index to 1, or you can say update the value of that element at the ith index that we are currently iterating on to 1, and we simply increase the counter value by 1, which means that we can plant one plant over there. Now, after the whole iteration is done, it would then go through the whole length of the array. When the whole iteration is done and the for loop has been terminated after the complete iteration, then it would simply check whether if the inputted number of plants that we want to plant inside the flower bed, which is being given as the input over here as n, is less than equal to our counter. Now, as we know, the counter represents the available spaces in which we plant our new plant without violating any rules of the flower bed, that we cannot, which is that we cannot plant two plants adjacent to each other. So to for that condition to satisfy, the basic thing is that either the number of plants inputted by the user is less than or equal to the counter. Now, if the it exceeds the limit of the counter, or the counter's value, then it means that we simply cannot put that many plant in that flower bed. So that's how the iteration goes in this whole code. Now I simply run my code. As you can see, both of the test cases have been passed, and now I have submitted. But yes, as you can see, my whole code has been submitted successfully without any problems, and it is showing me the runtime of 1 milliseconds, and it shows that I beat the 98.4% of the rest of the users that submitted the solution for the same code in Java. Now, coming to the time complexity of this question, the time complexity of this question would be constant, because it is running. Just let me second, just a second. Yes, the time complexity would be constant because it is running for the length of the whole array, not more than that or not decreasing than that, and each time the time of the length is constant in each iteration. That's why you can say the time complexity of this whole code is O of n, or you can say constant, because it is running only for the till the length of the whole array. Well, that's all. Thanks for watching.